In 1900, Max Planck proposed that amounts of energy are quantized, which means they can only have certain values. So, for example, it's an allowed value for you to have 2 siblings, or you can have 3 siblings, but you can't have 2.6 siblings. It's not an allowable value. It's an average value, but it's not an allowable value for you to have. Planck said that energy is the same way. It can come in this amount, or this amount, or maybe this amount, but it can't have just any old random amount. Bohr then used this idea in developing his planetary or Bohr model of the atom. Since Planck proposed that energy can only exist in certain quantities, certain amounts, Bohr said, well, okay, then electrons can only possess certain amounts of energy and not just any old amount, and therefore those electrons are only going to be certain distances away from the nucleus and not just any distance. So in the planetary model of the atom, we've got a nucleus represented by the N in the middle, and then we've got 2 orbits of electrons. And according to Bohr, you might find electrons in, say, either of those orbits. But you won't find any electrons in between, because for them to be in between, they would have to possess an amount of energy that doesn't exist. So that's where we get the Bohr model of the atom. This differs from Rutherford's model of the atom because Rutherford said, well, the electrons, they're just kind of orbiting the nucleus, just I don't know where, just in there. And Bohr said, nope, the electrons can be in certain orbits and not others. This brings us to the most up-to-date theory of the atom, which most people call the quantum mechanical model, but it's also known as the electron cloud model or the charge cloud model. There were many people, many scientists who worked on developing this model up to about the midpoint of the 20th century when it was mostly fleshed out. And it's complicated. The math behind it is too much for most people to handle. But in essence, related to what a first-year chemistry student should be able to understand, here's its essence. According to the quantum mechanical model, we never know for certain where the electrons are in an atom. But the equations of the quantum mechanical model tell us the probability that we will find an electron in a particular region of space around the nucleus. So, these 4 gentlemen and others developed this model that will never be able to tell us for certain where, say, an electron is in the atom, but will be able to tell us the likelihood that an atom is in a particular spot or not. Let me give you an analogy that kind of relates. If I'm at school teaching and a student were to ask me, Mr. B, where is your dog? I have to answer that I don't know, because I'm at school and my dog is not with me, so I don't know where my dog is. Now, I can tell you where the dog is supposed to be, since all the kids are at school and all parents are at work. The dog is supposed to be home in his crate, chilling out, meditating. But I don't know if he's there. I'd say there's a good chance that he's there. It could be that whoever was the last person to leave the house, and it wasn't me this morning, forgot to latch the crate, and therefore the dog is wandering around the house, perhaps sleeping on my bed. That's a possibility. Or perhaps the last person to leave the house let the dog out so that it could go to the bathroom before it was going to go into its crate for the day, and forgot that we needed to let the dog back in. I am sorry to announce that I have been guilty of this mistake a couple of times, not very often. So it's possible that the dog is in my backyard looking at the back door like, why isn't this door opening? Why have I been left outside? And it's certainly possible that my dog, being left outside, is wandering around the neighborhood doing things with other dogs that I don't think it should be doing. And just to keep things simple, I could assign probabilities to all of these situations. That's what the quantum mechanical model does. It assigns probabilities for where things like electrons are, or what particles might do, but it can never tell us for sure. Let's summarize Bohr to today. 1. Max Planck proposed that energy could be released or absorbed only in discrete packets called quanta. 2. Niels Bohr applied this idea to atoms, suggesting that electrons could only be at certain distances from the nucleus. The result was Bohr's planetary model of the atom, with electrons traveling in fixed orbits around the nucleus. 3. Throughout the 20th century, many scientists contributed to our current model of the atom, the quantum mechanical model. The quantum mechanical model is based not on the certainty of an electron's location, but rather on the probability of an electron's location within the atom.